to make a lactose.
And lactose is what? Cis or trans? Cis. And then we have glucose, right?
Yep.
Glucose, cis or trans?
Trans.
There we go. This is our glycidic linkage. It is a 1,4 glycidic linkage. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, so 1,4 glycidic linkage. And so what we want to do is we want to break this linkage. And so what we have is an enzyme, right? So this enzyme is a certain shape. Okay? And it's ran by a bunch of whole NCC, right? NCC, so forth. And let's just imagine on this C right here, we have a negatively charged one. Or here we have NH2, which can do some hydrogen bonding there. So this represents primary structure. And then if we had a second polypeptide chain, so N to C, and let's just imagine this had a carboxyl there, and then you have your NH. That's the hydrogen bonding. So primary structure, secondary structure, this is tertiary structure, and the combination of the two is quaternary structure. And so the idea of the enzyme is it is catalyzing this reaction. It's speeding it up by holding the molecule in place so we can get the dimer. So what we want to do now is understand how do these different environments affect the reactivity. So the first one, let's look at pH. So we had lows, what was it, 3, 7, 9, and 11?
Yeah.
How much yellow was it at 3? Meh. Right, not much. How much at 7? Pretty darn good, right? About 9? 11?
Faint. A little trace.
Nothing, right? Very little. How can we explain this? What is happening to the enzyme at this component? Yeah.
There's too many of both protons and OHs.
Yeah, so what type of structural level are we disrupting?
H bonding.
H bonding. So that can be in secondary or tertiary structural level. So we're literally denaturing the protein. So we're just changing the structural level. When you change the shape, you're going to change the functionality, which is going to get reduced. So how the environment plays a part. Okay? So that's pH. What's the next one? Let's do salts.
Salt.
Okay. Low, high salt. So 20%, 1%.
We did 1%.
What's going to happen?
Oh yes, get the bottom.
Reactivity goes down. What structural levels are we disrupting and why? We're disrupting tertiary structure. Our R group interactions, because this is ionic bonding.
Yes.
So we're going to disrupt this guy right here.
Mm-hmm.
NH2 plus, so as our positively charged. We're going to disrupt that. We can disrupt this. We can disrupt those things. That's going to be affected with that. All right. So what about temperature? Low, what's it like? And then when we get to high, 0.
Mm-hmm.
What is happening?
The molecules are moving faster.
So the molecules are moving faster. We're doing good. We're doing good. We're doing good. And then
Breaking and dehydrating.
the protein itself breaks apart. What structural levels break apart?
Primary structure?
Everything, yes.
Oh.
So primary structure all the way through. So if you disrupt primary structure, you disrupt
Everything.
everything.
2 to 4.
So
everything.
when you go and cook your food, you're heating it up to an extent that it breaks the bonds. So typically we want to cook our meats and stuff to like 170 degrees Fahrenheit. And the idea is that that will disrupt all of those bonds and break things in the bacteria. That's the bacteria and the parasites that we actually care about. And so that's why we hit a certain temperature threshold, because you're breaking these down. That make sense?
Mm-hmm.
Okay. Next ones. Let's do our sugars. So what sugars do we have? Sucrose. What's another one? Lactose, right?
Mm-hmm.
We had glucose and galactose. How much reactivity was sucrose? Yeah. What about lactose? Not much. Now that's interesting. What about glucose? A lot of activity. And galactose? Bunch of activity. Why is there so little activity with lactose? What's the enzyme want to do when there's lactose present? Break it. Shouldn't, so do you think the enzyme is doing that? Yes.
Oh, yes.
But you have ONPG as your indicator. So if lactose also fits in there, does the enzyme know the difference between ONPG and lactose? So it's going to break them equally. So it's going to appear less because it's competition with ONPG. This is competitive inhibition. Competitive just means two things are fighting for the active site. This is the active site. A molecule fits in there. Lactose fits in there. ONPG fits in there. So either one can fit. So the overall reactivity of ONPG will be lower than that. So if you have this one, so if this was at 1 minute, at 10 minutes, it might be there because it's finally used up everything and is now yellow. What about sucrose? It's a little different, right? It's a little bit different shape than lactose, but is it similar enough? Yeah, it's probably fitting in there. It's a dimer at least. And then these guys, well, what about glucose? Glucose would fit, but glucose is the product of this. So the moment glucose is made, what happens to it?
It's broken.
It goes away. So it'll bind in there a little bit really quickly and then immediately fall out. Same with lactose. Comes in, falls out. Comes in, falls out. It's not actually taking up much time. So the reaction's able to move forward. Feel about that. This is competition, competitive inhibition, competition. All right, what about milk?
We did lactose.
We did lactate.
You did lactate, and so how did you set up the experiment for lactate?
We got
Same,
The same.
The same.
Why is same the wrong answer?
because it's not a milk, or it doesn't have the the enzyme.
What should lactate milk
I mean,
have in
the
it?
protein.
lactose.
Should not have lactose in it. You're
Oh.
drinking lactate milk because you are lactose
Intolerant.
intolerant.
So,
So
it shouldn't have
what
lactose.
should be in it? Lactase. The
Lactase.
enzyme should be in it. So did you need to add the enzyme to that experiment?
No.
No, this is me tricking you.
Ah,
See if you actually were thinking about what you were doing. So let's take an experiment. So what should I do for this experiment? Add the ONPG. We know it should work.
Can
so
we do it
this.
again? Okay. Oh,
We
he's
take
doing that.
lactate milk. We pour it in there. Take the whole damn bottle. That's how I do chemistry. And what happened?
Ooh,
Nothing.
What do you ooh?
Nothing.
I thought I saw yellow.
Come up with an explanation why nothing happened.
Wait, I need my glasses.
Talk to each other. Why did nothing happen?
It's like it exploded or something.
It did not turn yellow, therefore the enzyme is not
Ah,
there.
The enzyme is not there.
But should the enzyme be there?
no.
Yes,
Yes.
100%.
Why?
Do you think this company is making lactose It's just putting their thing on saying the lactose is really gone and it's not.
I mean,
I would hope they're not, right? Good way to get sued. So, what happened? What did they do to the milk? Talk to her. Think about this. What did they do to the milk? Why is the enzyme not working?
Because it's made out of baking powder.
They
Liquid baking powder.
You like my chemistry? Just dump it all together.
Yeah, I love it.
Drives me.
What I like is my reaction. I was like, whoa! Nothing happened. And I'm like, whoa!
That's okay, the enthusiasm was there.
I thought it was turning yellow. I thought I
So, I taught chemistry class not a while back, and we had to do titrations. I'm way too ADHD for titrations. I'm just like, shh, that's about right. Done. You know, it's like, well, you can't do that. I'm like, I did.
Yeah.
Don't do what I did. See, I was the kid to calculate it all out before I went in, so I knew how many milliliters you were supposed to add, and then I would get it done in like 15 minutes because I would be like, oh, it needs 18. I'll go to 17 real fast and do the last milliliter real slow.
So
Yeah,
you
that's
did-
right. Don't ever do what I do. That's my life lesson. Why did it not turn yellow? What did they do to the milk? They boiled it, they pasteurized it.
They
The milk has been
pasteurized it.
pasteurized, therefore they held it under extreme heat and temperature, extreme temperature and pressure, and there is nothing left in that milk. So, have any of you tried lactate milk before?
I haven't drank lactate.
So, those that like regular milk do not like
Lactate.
lactate. Why? What does it taste different as? It's sweet. Please explain to me why it's sweet. All the lactose got broken down into glucose. So it is sweeter. Ah. Now it starts explaining this. So lactate milk is sweeter because it has no lactose in it. It's just a different type of sugar. It's the component of sugar. So we want to start understanding how these reactions work because it's really important, because starting after next week, we're going to dive into how to construct the enzymes. How are we actually going to go through the process to build? You all know the components of the enzyme. You know how to build the amino acids now. You know how to build the polymers. You know all the structural levels. You know what the enzymes are doing with breaking down the saccharides. After the next exam on Friday, we're going to start taking our DNA molecule, and you'll be able to construct that DNA molecule. Actually right now, every one of you should be able to build that. Okay, you know the chemistry behind it. You know the ribose, you know the phosphodiester bonds, you know the nucleic acids, but we're going to actually be able to build through that. And then we're going to be able to translate it. So transcribe and translate it so we can build an enzyme, so we can understand how regulation works, so we can build up our model. Okay? How do we feel about all this? What are we doing tomorrow? Go to office hours on Zoom tomorrow, okay? Because there's a lot of information. And then we might want to do one next week sometime, maybe like on Tuesday or something, because we're not going to see each other until next Wednesday, when we're going to cover lipids and understanding how to build all those, and we have another worksheet. And then what's next Friday? An exam.
The
Now,
test.
the good news about this exam is how easy should it be?
Very.
Really easy. If you know how to construct a saccharide, you know how to construct a peptide, you understand these bonds, electronegativity, you understand how to build a protein, this exam is super easy. It is just literal chemistry. So don't fall behind, ask lots of questions. Let's nail this shit, because honestly, this is easy.